Frequency distributions, the second chapter of first module of the course Math 5D02 Mathematics for Natural Sciences. First, we introduce some basic concepts of data. What is a raw data? Data that have not arranged numerically are called raw data. If we arrange the data in ascending or descending order, we call it an array, and the difference between the largest and smallest data is called the range of the data. Now we introduce the term frequency distribution. If we arrange the data in a table together with the corresponding class frequencies, it is called a frequency distribution. That is the number of occurrence of data. We illustrate it using the following table. Consider the height distribution of 100 students in a university given in the following table. The height in inches of 5 students is between 60 and 62. 18 students is between 63 and 65. 42 students have height between 66 inch and 68 inch. Likewise, this is a frequency distribution. Next, we define the term class interval. A symbol defining a class such as 60, 62 is a class. That is, the students with the height range 60, 62. And the n numbers 60 and 62 are called the class limits of the class 60, 62. 60 is the lower limit and 62 is the upper limit of the class. Class boundaries. When we record the in height 60 inches, we consider all the values from 59.5 to 60.5 even. So in the class 60-62, we consider all the values between 59.5 and 62.5. So these values are called the class boundaries of the class 60-62. And the size of the class is the distance between or difference between the class boundaries. And the midpoint of a class interval is called the class mark of the class. General rules for forming frequency distributions. Now we are in a stage to form a frequency distribution using the raw data. Suppose we have a raw data. First we find the smallest and largest values of the data and hence its range. Then divide the range into convenient number of classes, keeping in mind that the number of classes is between 5 and 20 normally. And as far as possible, the observed data should not be class limits. The third step is determine the number of observations in each class intervals or class frequency using tally marks. For example, from a frequency distribution using this data, first we shall find the smallest of the value of the data. For that, we find the smallest of each row. Smallest of each row and the largest of each row. Smallest of first row is 62 and largest is 93. Likewise, we can circle the smallest and a rectangle, mark a rectangle for the largest value. Then we can find the smallest and largest of this data. It is found to be 53 is the smallest value and 97 is the largest of these values. So range of the data is 44. We divide the range into 5 or 20. So when 44 is divided by 5, we get 8.8, and 44 divided by 20 equal to 2.2. So the number of the class size lies between 2.2 and 8.8. So the class size may be 3 to 8. 3 to 8. So if we choose class size as 5, we get this frequency distribution. Note that our smallest data is 53, but we start from 50 and end at 54. 53 do not come as a boundary value. Okay, so this is the method for forming a frequency distribution. Now we are in a stage to represent a frequency distribution using histograms and frequency polygons. What is a frequency histogram? It is the set of rectangles based on x-axis with the centers at class marks and length equal to class size and area proportional to class frequencies. But if we draw a line graph of the class frequency against the class mark, we get a frequency polygon. Now, cumulative frequency distributions and achieves. The total frequency of all values less than the upper class boundary of a given class is the cumulative frequency up to and including that interval. A table presenting cumulative frequencies is called cumulative frequency distribution. A line graph showing the cumulative frequency against the upper class boundaries is called the cumulative frequency polygon or OG. For example, consider the height distribution of 100 students we given earlier, that is the height 60 to 62. So how many students have height less than 59.5? We have considered students with height 59.5 to 74.5 as class boundaries. So less than 59.5, there is no student. But less than 62.5, there are 5 students. So our frequency table is like this. Less than 59.5, there are no students. Less than 62.5, there are 5 students of the first class. Less than 65.5, there are 23 students. How? There are 18 students in the class 63, 65 and 5 students in the class 60, 62. So less than 65.5, there are 18 plus 5 equal to 23 students. Proceeding like this, we get the cumulative frequency less than 68.5 is 65, less than 71.5 is 92, and less than 74.5 is 100. This can be depicted as a line graph, and we get the cumulative frequency curve or achieve like this. This is the end of the video.